Hello everyone, I'm Bob Ward from Microsoft. Welcome back to a special edition of Azure SQL for Beginners on Performance, a guide to performance troubleshooting for Azure SQL. In today's episode, we have another scenario to look at, and this is a waiting problem due to deadlocks. Now you remember, in our overall scheme of looking at performance problems, running versus waiting, it's either high CPU or low or no CPU. And in this particular case, in this scenario, it's a scenario that's waiting because we see low or no CPU. And if you look at all the scenarios we've done, we've covered several. Last time we covered a waiting problem with blocking. This time we're going to look at a waiting problem due to deadlocks. We'll look at the signature of the problem, how to detect this, how to look at more information, and techniques and tips on how to resolve it. So what is a deadlock? It might help you know more information about this as you're actually going and looking at one of these problems. Consider this scenario. I've got one session that owns an exclusive lock, like a key lock, a row lock, against a product table. I've got another session that owns like an update lock or on a key lock on a product description table. Now let's say that session B tries to run a query that requires a shared lock against the product table. Well, it's going to get blocked on that specific key lock. And if session A needs a update lock, let's say, on that key lock on the other table, it gets blocked as well. This is a problem. Like, what are we going to do? This is what's called a deadly embrace. We're deadlocked. So instead of letting these processes just be hung, SQL Server can detect these deadlock patterns and decide to pick what's called a victim. And if it picks a victim, what it does, it rolls back a particular transaction and returns an error 1205 to the application. This is a classic signature of a deadlock in SQL Server. In addition, one of the things I want to talk about that we're going to show you in today's episode is something called Azure Diagnostics and Kusto, our KQL query language. So did you know that in Azure SQL database, you can set up diagnostics to feed certain types of detailed data like errors or deadlocks or wait statistics to what's called a log analytics workspace. Once your data shows up in that log analytics workspace, you can then use what's called the Kusto query language, or KQL, right in the portal to go query log information and get detailed diagnostics, like in this case you see here, deadlocks. You'll see an example of how we're going to use this today to diagnose more information and details about how a deadlock is actually occurring. Now, we've used the troubleshooting process before, a concept to tell you a methodology in each scenario about how to go detect a problem and how to resolve it. And let's look at it for a deadlock scenario. So let's say we identify low or no CPU. We then go look for top resource consuming queries, and what we find is that there's no blocking going on. We check to see if there's blocking using DMVs, and there's not a persisted blocking problem. Maybe it's like intermittent. So what could be happening is, in this intermittent blocking problem is that there could be deadlocks occurring, because a block could occur and SQL Server could choose a deadlock victim to ease the blocking problem, but you're not seeing it in action. So you need to go get more diagnostics to see if that's going on. And once you see those diagnostics that deadlocks are occurring, you need to apply best practices, which we'll talk about on how to avoid these deadlocks. So with this process in mind, let's go see this in action. It starts with, again, the AdventureWorks sample database. I've built a new one here, but when I deploy the database, I pick the sample option, which gives me that AdventureWorks sample. So all the different queries you see in the examples are going to be based on the AdventureWorks sample. So let's go and use that process again of looking at the Azure portal to see, is this a running versus waiting problem? Using the monitoring tab, I can see I've got low or no CPU. The chart, the numbers look big. I mean, the graph looks big, but the numbers are low. You see, it's a very low amount of CPU. So in my mind, this looks like a waiting problem or low or no CPU problem. So I got to dive in further. I got to dive into the query store. I may have to use DMVs to see what's going on. Let's go do that. So back over to our database, I'm using the query store, looking at top resource consuming queries, and I do have a couple of queries here. And these particular queries look like they're modification queries. They're both update queries. And I can go look over here to the right and see like their duration. And in fact, you can see hovering over this dot right here that there is a fairly long duration for these queries, which since there's no CPU, it could be they're blocking. But notice this in the graph. Look at this triangle here. If you hover over it, you can see the query store has detected that in some cases for these queries, the execution has failed. So that's a really cool thing about the query store. If a query fails for some reason, the query core can detect that it actually had failed. And because I see high duration here and low CPU, maybe I've got a deadlock type problem. So what I'm going to do is I'm going to run a blocking query first to see, do I see intermittent blocking? Do I see any blocking? And I'll run it a few times. In this particular example with my workload, if I'll go run these DMV queries, which again, it's all in your workshop examples, I don't see any blocking going on. But it's possible when you run this yourself, you might see intermittent blocking happening. So how can I tell if a deadlock's occurring? This is where Azure Metrics can help you. So back over to the portal, we'll go down to that compute utilization that we talked about before, and we're going to click on the chart to see if there are any metrics in a more detailed fashion that can tell us, are there deadlocks actually happening? So clicking on the chart and going back and changing that time granularity like I did before to the last 30 minutes every 1 minute, I can click in and I can go add a metric. So clicking on add metric, scrolling down to my list. We used sessions before, but if you scroll down here, you can see deadlocks. Ah, look at that. The chart is showing us that we do have a fairly significant number of deadlocks happening on a continuing basis. Like every minute, we're seeing a large number of deadlocks occurring. Well, here's the problem though. I need more information about these deadlocks. So how do I get Diagnostics to show me about what's happening in the system? This is where Kusto and Log Analytics and Diagnostics can come into play. So I've set up Diagnostics already in my system to capture things like deadlocks. I can go in the Azure portal to Logs, and once I click on Logs, I'm able to run what's called a Kusto query. And I've built an example for you that I'll paste in here to show you how to go look for deadlocks in this case. So I'm going to look at deadlocks, I'm going to run this Kusto query here, and sure enough, if you let this run for a few seconds here, I've got a bunch of deadlock events captured by the system. Now, one of the cool events here is called a deadlock XML file, a deadlock XML graph. So what I love about SQL Server is I can take this XML, which is kind of maybe hard to go interpret. I can copy this, save it into a file, and see it visually in Management Studio. Let's go see that. So I'll take the XML file, I'll save it as what's called an XDL file. So I called it deadlock.xdl. I saved it, and I opened up that file in Management Studio, and look at this. I have this really neat visualization of what happened during the deadlock. And if you kind of drill in here by looking at what the requests look like and the object IDs, the names aren't shown, but you can look up these object IDs in your catalog views. I can see that classic pattern of an opposite order transaction. One session is updating tables in one order, one session is updating tables in a different order. And looking at the query store here, I can see what those updates look like. So now I've got a lot of great information here. I know the deadlock's occurring, I know the tables involved, I know the queries involved. I can go to my application developers, or me as a developer myself, I can ensure that I'm actually acquiring locks in the correct order, therefore avoiding deadlocks. So, what are some of those best practices for avoiding and handling deadlocks? Number one, updating tables in the same order in your app is the sure way to ensure you won't see deadlocks or you'll mitigate these as much as possible. But number two, keeping transaction as short as possible will help you. There are scenarios where longer transactions will run into deadlock scenarios, even on things like index locks. So tuning queries and using indexes are always a great practice. And in this case, making sure you have your queries tuned and using indexes can shorten query durations, therefore helping to avoid deadlock problems. And make sure you're using the right isolation levels. We talked about the read committed snapshot isolation level, which is the default for Azure. Make sure you're trying to use that in your application. Don't turn that off in Azure Database to help you avoid blocking, which of course could help you avoid deadlock problems. And finally, most important, deadlocks may be something that are just inevitable in your application. So what I always recommend developers to do is put retry logic in your app for this message 1205, which is the error you get back when your session was chosen as a deadlock victim. It could be a simple retry in your application will avoid a persistent deadlock problem and keep your application workload running healthy and tuned. So in summary, we looked at a running or waiting problem. In this particular case, it was a waiting problem because of low or no CPU. We didn't have persistent blocking here, so we kind of came up with a theory that a deadlock could be occurring often in our application. So we looked at deadlock diagnostics to prove that was the case. We took a deadlock XML file and visually saw our deadlock in Management Studio to determine it was updating tables in the wrong order that kind of led to this problem. And we talked about what best practices you can use to avoid deadlock problems in the future. And we want to make sure you have all the resources you need for these kind of problems. So look at the top. Here's a great resource to learn more about SQL deadlocks, how they occur, why they occur, and how you can avoid them in the future. And of course, all of our great resources from the beginner series, the workshop, which includes scripts and examples to see this scenario you saw today, and other videos, learning paths from our team to learn all aspects of Azure SQL, and even books to dive deeper on the topic. I hope you learned a lot from today's episode about a waiting problem due to deadlocks. Looking forward to seeing you next time on the special edition of Azure SQL for Beginners on Performance.